Well, I don't know about you, but I've actually quite enjoyed playing with this alarm board. Amazing how much fun you can have something you just found free in a skip. And I can't claim to understand all the functions of it, or how all parts of the circuit work, but I think we've had a good look at it there, and yeah, I think we'll make number 4 lucky number 4, and I think we'll finish on that. So what I was hoping to do today is we still haven't had a look at this RF transceiver. I think I'd like to have a quick look what's in there. We've also got this second microprocessor on here, this NXP, and I looked up this number earlier, and this NXP processor is, I think I've forgotten already. Basically it's a more modern version of the 8051, or basically it'll run with the 8051 code. It'll run that version of code, and the 8051's a pretty old microcontroller. It says it's only got 512 bits of RAM, and I'm guessing that's why it's using this external static RAM chip that we looked at the other week. And it's also not got a huge amount of ROM either. And one thing I would like to do is, I'm pretty sure that this NXP processor it's in some way using this one-time programmable EEPROM here. So I was wondering if we could actually read the code off this EEPROM and see if there's anything, any Easter eggs in it. Maybe the guy who programmed this has left some swear words in it, which is always nice to see. And the other thing that I found interesting was this, although it doesn't sound very interesting, is the way this piezo sounder operates, because I was messing with it the other day and I found one or two quite interesting things about it. So let's have a look at these, and we'll see where it gets to. Now, back in the day when I started getting interested in electronics, which is well over 30 years ago now, most of the boards that you made were single-sided circuit boards, and then I remember we went to these very exotic double-sided boards. Well, this board is actually a multi-layer board, because I can actually see when I hold it up to the light, and I'm hoping the camera will make it out. Can you see there's a faint grey track there? Maybe rather than looking at my finger, poke at it with that. There's a black track there. Hope you can make out the outline. Well, that track's not on the top layer. And if we turn it over, it's not actually on the bottom layer either. So where is it? Well, this is a multi-layer board, and I'm guessing it's maybe got 4 layers. I'm not exactly sure, and I don't know a way of finding out how many different layers there is. Maybe all you do is hold it up to the light and yeah, look through it and try and count them. But I think there's at least 3 layers on this board, maybe there's even 4. But one of the things about having these multi-layers, and what you can see, very large ground planes, you can see there's more or less all copper here on top, and if we turn it over it's more or less all copper here. So these are ground planes, and what these will have been put on for is actually for screening purposes. Well, that's one of the main reasons they will put on. So what they'll have actually done is all the actual high-speed digital lines that might cause EMC noise and stuff like that, they've actually trapped them wires between a top layer of copper and a bottom layer of copper. And that's all well and good, but one of the things is it makes actually backwards engineering the board really annoying, because I can see these lots of little round dots, these vias, where tracks within the board are going to different layers, but I can't see the tracks themselves. And one of the things I've been playing with here is just trying to backwards engineer this LCD. Now this LCD module uses what they call, well, I don't know if it's what they call it, it's what I call it. They call it the Hitachi interface. I don't know, I'm assuming Hitachi must be one of the first companies that developed a standard interface for these LCD modules, and most of them follow a very, very similar pattern. And what I've been trying to do is actually just find out which of the 2 micros this LCD is connected to, and I've not had a lot of luck, to be honest. Now these LCD displays, they're actually controlled through these pins here, these connections along here, and most of them follow a pretty similar format. The first pin here is the ground connection, and then you've got the supply voltage, which is 5 volts, and then the next pin here, pin 3, is actually a contrast control, because I'm sure most of you have had to adjust the contrast on products of your own that have got an LCD, and I'm not exactly sure why you need a contrast control. I'm not sure if it's because you know, there's some natural variation in the process of manufacturing these LCDs. I mean, maybe part of it is personal preference, but one of the things that I have noticed when I've used equipment that, you know, we install outside is on very cold days you might often have to readjust the contrast control, and that the way that's achieved is usually just a variable resistor which puts a voltage on this this pin 3 here, and this LCD is no different from that. If we turn that over, we've got this potentiometer here, and what we'll do is we'll just adjust that, and I can show you the effect of that on the LCD display. Now I've got our fluke meter here just connected to the DC volts range, and I've just connected it via a soldered on wire to the contrast control on the LCD. So let's just power that up. And usually it's about 0.7 of a volt, the contrast rate. Oh, actually there we go, 0.7 of a volt. Is that going to come up? Come on, wake up, wake up. It's just doing its thing, self-test. There we go. So it's come up with the words house alarm. And what I'm going to do is, well, first of all, oh no, it's bleeping. Oh well. So this is that. Sorry, anxiety levels are running high today. Just one of the days where I'm just generally feeling very bad-tempered. Right, okay, let's have another go. So we've got the voltmeter connected up to pin 3, which is the contrast control of the LCD. And you can see that the display is on at the moment. Hopefully you can see that. So you're getting some reflection from the lights there. So you can see that if we adjust this control here, it has an effect on the voltage reading. Typically these voltage controls range from about 0 to about 0.8 of a volt. So just turn that around again, and hopefully we can get you in so you can see that without any reflections. And I'm just going to turn that again and observe what the voltage level is on the fluke meter, and just have a look at the contrast on the display. So basically, with the contrast turned down to minimum, it's actually at full voltage, and then when we actually increase the contrast, the voltage drops. And you can tell when you're increasing the contrast because the actual squares, the matrix that makes up the LCD, they start to become visible. But again, sometimes that's something that happens on very cold days. I've noticed that if you look at some of these LCDs on a cold day, you can actually see not just the elements which are actually you know, set to black. You can actually see the other elements which aren't. So yeah, I'm just turning that up and down, and you can see that as I change this potentiometer control, the voltage on the contrast control changes and the contrast goes up and down. So I think that's a little bit interesting, and yeah, I'm sure you've all had LCDs and had to adjust the contrast from one time to another, and that's how it works, by a voltage control connected to pin 3. Now, just going from memory now, we've got a few more control pins here, and these are something like I think this is a register select pin. Then there's actually a read-write pin here, which you have a controlling microprocessor, and that microprocessor may choose to write data to the LCD, or it might actually choose to read data back, maybe the contents of the display or what some register setting is. So depending on whether or not there's a high or low on this pin here, it will tell the LCD whether it should be expecting to read data or write data out. The next pin here is an enable pin, and then you have the data lines here, which is data line 0, 1, 2, 3, 4, 5, 6 and 7, because it's an 8-bit data you normally write to these. Well, actually, depending on the mode you configure this display in, there's two typical modes. I think there's a 4-bit mode or an 8-bit mode, because you may not have it might be quite a luxury if you've only got a small microprocessor. Back in the day you didn't have hundreds of pins, so what they would allow you to do is you could either write one 8-bit word, or if you didn't have that many pins you would actually write 4 bits, but write more often. So yeah, you don't necessarily have to use all 8 bits. You could use the first 4, or you could use all of them. Yeah, it was something like that anyway. Now, I've just been on the interweb and I've got some examples of some data we can write to this 8-bit data bus. And there's two types of data. There's actually instructions, and then there's the data itself. So this first little table here is telling you the various instructions you can write to it. So you can write things like clear the display, or you can return the cursor to a home position, or you can set the entry mode. I don't know what that is. Cursor or display shift. So you can send various instructions to do with manipulating the actual cursor. So if you wanted to clear the display, for example, let's go to the top one. On the data bus you would put 1 0 0 0 0 0 0 0. Write that to the data bus, and that would result in all the text disappearing on the display. Now the actual data that is displayed, that comes from this other table here. And the way this table is arranged, it's arranged into rows running that way and columns. Now the rows represent the lower 4 bits of data, and the columns represent the higher 4 bits. So let's just pick a character at random. Let's pick a P. So if we want to display the letter P on the display, typically what would happen is we would first of all send an instruction telling the cursor where to move to on the display, whether it's the first line or the second line, and maybe whether it's the start of the line or the end of the line. So we would send that instruction. Once that instruction was sent, the cursor would then move to that position on the display. The next thing we would send is the actual character we want to display. So as an example, let's send a character P. So we would send 0 0 0 0. All those would be on the first 4 bits of the data bus, and then the upper 4 bits we would put 0 1 1 1. So if we wanted to send the letter 1, we'd send 0 0 0 1, then look up that one, 0 0 1 1. Now depending on the mode that you set the display up in, you may have to actually shift the cursor, because when you've written the P you might have to move it one position to then write the 1, but that isn't necessarily true, because you can set up this display in a particular mode where as soon as you write one character, when you finish writing it automatically increments to the next display, to the next position along. Oh god, bored, gonna do something else. And what that something else is, I thought we could just pull this chip out and stick it in an EEPROM programmer, well, an EEPROM reader, and just see if we can suck any code off it, and you never know, we might get lucky and find some Easter eggs that somebody's left us. You know, I really wish I had one of those chip pullers, and I don't have one. I seem to remember I bought one from Maplin's years ago. Was it Maplin's? No, it might have been Tandy, and yeah, it was quite useful, because you always kind of run the risk of trying to get these things out of bending all the pins. In fact, this one doesn't seem to really want to come out, it's quite tight. Let's get that off. Get over there, why won't you come out? Anyway, we're going to have a go at reading this in my Mini Pro programmer, and yeah, they're only cheap from China, but they actually seem pretty good. I've only used it a couple of times, but a couple of times I've used it, it's worked really well. An AT27 CO40, and I seem to think it was it a 512k static EEPROM? I don't know, can't remember. Anyway, let's hope this Mini Pro can actually read one of them. Press read now. Doing something. Reading code memory. Okay, it's finished that. You can just see that there's some interpreted ASCII here at the right hand side of the screen. So I'm assuming that this stuff on the right here is interpretation of what's on this this line here. So I'm just looking at, oh, I don't know what I've done now, pressed a button. It's got things like 6, Friday, FRI min, second digit level month, count, period, zone, select, code, pulse, attrition, so it appears to have some information about key fob codes. Ah, right, okay. What I think these are is that's making a bit more sense now. These are menu instructions for the what appears on the LCD display. So all the things that, all the different words and things that the alarm's capable of saying, it looks like they may be stored in here as some kind of I don't know, some kind of lookup file. Button model, delete. Are you sure? No error, no free slots. Yeah, I'm sure all this will mean something to people who operate these alarms. I was really hoping we'd get some rude words or some swearing in here somewhere. If I wrote some software, I'd put something filthy in there somewhere, I'm sure I would. Well, I'm totally disappointed with that. There's no rude words or filth. Let's put the memory device back in. Let's see if we can do that without bending all the legs on it. I did manage to get it in without bending the legs, that's somewhat surprising. Now, is it going to work, or have I totally stuffed it? We have life. So I think it would be interesting to find out what frequency this little RF transceiver operates on, and there's various ways we can do that. Well, we could try and use my very favourite piece of test gear, which is the Marconi 2955, and we could also try using one of these quite excellent and very low cost software defined radios. Now, this is my Marconi spectrum analyzer, and it consists of two parts, which is the display unit, which is a 2380, and then it's got the RF goodness bit down here, which is the 2382. Now, I bought this about 10 years ago, and it wasn't new then, and basically I had to sell both my kidneys and my left testicle to afford this, and I absolutely love it. It's been really good, but unfortunately the frequency response only goes up to 400 megahertz. And I remember when I bought this, I thought, why on earth would you ever need more than 400 megahertz? I mean, God, you could fly to the moon on 400 megahertz, but in just a few years, frequencies have gone up and up, and you've got all the Wi-Fi stuff now, and your cellular phones, and even this little data link on this alarm is operating at 870 megahertz. So it's been left a little left behind. because probably for about a 20th of the price of one of these, you could go out and buy one of these Rigol or Siglent spectrum analyzers, which are absolutely excellent. But I've got to admit, I wouldn't be without this for the world. It is so easy to operate. There's a button for everything. It's got an oven-controlled oscillator in here, which is super accurate. In fact, it's so accurate that I really can't even find any offset against my my satellite disciplined oscillator. It is absolutely bang on, and yeah, I really wouldn't want to be without it. But unfortunately, we can't use it today because it only goes up to 400 megahertz. Well, we could try using a radio scanner, and to be honest, that'd probably work just as well as anything. Or of course, we could try using the Schlumberger SI4015 Stabiloc. But to be absolutely honest, that really is about as much fun as nailing my testicles to a piece of wood and dragging it round the streets. This thing is just absolutely painful. Oh, God, I don't know why I bother. Why is it so hard? Is that enter? No, of course it's not enter. That'd be too bloody obvious. Select units. When does it enter? Oh, back to there. Oh, bloody thing. Germans. Oh, and by the way, I found a little bit of a shortcut to figuring out what frequency it's on. It's actually written on the back.